In order to work with definite integrals, we need to work with these sums. So the following are a couple formulas that we're going to use in order to work with sums. First one says if we are adding up 1 plus 2 plus 3 up to n, what we can do is exchange this sum of the i's for n times n plus 1 over 2. If we have the sum of the I squareds, we can use the formula n times n plus 1 times 2n plus 1 over 6. And if we use the sum of the i's cubeds, then we have n times n plus 1 over 2 quantity squared. We're going to have to remember these formulas because we're going to use them within our problem, so you probably want to memorize these. Some rules that allow us to work with sums is, first one, if we add c plus c plus c over and over again n times, that is n times c. The next one says that if we have a common factor of c, so a changes, depends on the I, but c is constant throughout the whole problem, we can factor out that c. So what we're looking at is something like c times a1 plus c times a2 plus so on. There's that common factor, so we can factor out the c. If we have the sum of a sub I plus b sub I, well, adding a1 plus b1 and then a2 plus b2, we could rearrange the sums and add up all the a's together first and then add up all the b's together next. That's what this rule says. And if we're subtracting, we can do it with subtractions. So we want to use those formulas and those properties in order to evaluate this definite integral of x cubed minus 6x from 0 to 3. So we know this is equal to the limit as n approaches infinity of the sum from 1 to n of f of x sub I times delta x. In order to do this, we need to know what delta x and x sub I are. Delta x is upper minus lower divided by n. So 3 divided by n. X sub I is lower plus delta x times I. So our f of x sub I, there's an I right there, f of x sub I is x sub I cubed minus 6x sub I. Well, what is that? That is 3 over n times I cubed minus 6 times 3 over n times I. Okay, so now using all of those, what does our formula become? Well, it's the limit as n approaches infinity of the sum from 1 to n of 3 over n times I cubed minus 6 times 3 over n times I, that's the height, times the base. Okay. Now, we've got to evaluate this limit. In order to evaluate the limit, we need to know what that sum is equal to. Notice a couple of things here. The sum is dependent on I. I is called the index of this sum. We need to work with I. I is our variable. In terms of the limit, n is the variable in terms of the limit. So we can use properties of summations from up here, and we can use properties of limits from our earlier chapter. So what can we do to make this look better? Well, first thing that I notice is that 3 divided by n is a constant in terms of this sum. So I can factor it out of the sum. So I've got the limit as n approaches infinity of 3 over n times the sum from 1 to n of, what do we have? We have 27, I guess I don't need parentheses here, 27 over n cubed I cubed minus 6 times 3 over n times I. Now, we do have a sum there, and then close that off. Okay, so we used our factor out the constant. Next, if I look inside of here, it looks like the sum of a sub I minus b sub I. So I can use that last property, which allows me to split the sum up. What's my goal anyway? My goal is to be able to use those formulas that we've memorized now 3 minutes ago. Our goal is to get some summations of i's or I squareds or I cubeds in order to use those formulas. That will change our problem from being in terms of i's over here to being in terms of n's, which is what the limit is in terms of. So I've got 3 over n times the sum from 1 to n of 27 over n cubed I cubed minus the sum of 18 over n times I. Okay, so that was a property. Next, let's factor out those constants in front of their summations. So we have the limit as n approaches infinity of 3 over n times 27 over n cubed times the sum from 1 to n of I cubed minus 18 over n times the sum of I. Okay, this is where we want it, because now we know that the sum of I cubed and the sum of the i's can be written in terms of n. We just have to remember what they are. Okay, we don't remember. Sum of I cubes is n times n plus 1 over 2 squared. The sum of the i's is n times n plus 1 over 2. Okay, great. So we're going to use these two in our problem to get rid of that summation notation and write it in terms of n instead. Okay, so all I'm going to do is swap out that highlighted stuff. So limit n approaches infinity of 3 over n times 27 over n cubed times, this was, what was it? N times n plus 1 over 2 squared minus 18 over n times, what was this one? N times n plus 1 over 2. Great. So now we just have a limit to deal with. It's a matter of just simplifying these until we can evaluate the limit. So what I'm going to do is I'm going to start multiplying stuff out. I think I will start with the insidemost squaring and work from there. If I square this, that gives me n squared times n plus 1 squared over 4. minus, I think I'll distribute, oh wait, I don't have to distribute that. I can simplify, n goes into n. And now I'll distribute the, oh, let's not distribute the 18. Let's simplify that and make it a 9, and let's distribute the 9. So minus 9n minus 9. Okay, watch out because I'm distributing negative 9 to n plus 1 there. Okay, so that's about as far as I can go with that part right there. Let's see what else we can simplify. N cubed and n squared, and I still have one of those n's left in the denominator. Looks like that's it for that one. So we have the limit as n approaches infinity of 3 over n times 27. Now we can FOIL out this n plus 1, giving us n squared plus 2n plus 1 up top. On the bottom, I have 4n. Got my minus 9n minus 9. Okay, and I think now let's multiply in the 3 over n. So we have the limit as n approaches infinity. 3 times 27, what is that? 54 times n squared plus 2n plus 1 over 4n squared minus 9n over n. 9 times 3 is 27n minus 27 over n. All right, getting closer. N into n, cancel out. Nothing I can do with that last one. Wait a minute. Shouldn't that be 50? I think that's 51. Guess I should probably check my calculator, since I apparently don't know how to multiply here. 3 times 27 is 81. Sure. Yeah, that's better. All right. So now we need to simplify this a little bit more before we take the limit, because we'd end up with some indeterminate limits if we try to do it right now. So I have 81 over 81 times n squared. 81 times 2, I'm just going to leave that as 81 times 2n plus 81. Each of those are over 4n squared, 4n squared, 4n squared, minus a 27, minus 27 over n. So now it looks like I can simplify n squared into n squared. One of those with one of those, nothing cancels out there. Now we can evaluate our limit. The limit of 81 over 4 as n approaches infinity, well, there aren't any n's there, so it's just 81 over 4. Plus, okay, 2 times that is 162, but there's no n's on the top, but there are n's in the denominator. If there are n's in the denominator, then the denominator is getting huge, but the numerator is staying as a number, so that limit goes to 0. 81 over infinitely large number is 0. There aren't any n's there, and then 0 there as well. So we've got 81 over 4 minus 27 is negative 27 over 4. I used the calculator for that one, so it's right this time. Okay, well, wait a minute. Negative 27 over 4. All of that gave me negative 27 over 4. How do we get a negative 27 over 4 out of all that? Well, it's important to know what it is that this function is doing. X cubed minus 6 actually looks something like this. It's got an intercept at 0, 0, and then it kind of goes through like that. So what's happening is we're getting a kind of think of an area 1 and an area 2. But since area 1 is below the x-axis, if I were trying to think of this as a base times a height, what kind of f of x does this give you? It gives you a negative number. So when you do a base times a height, you end up with a negative number. That is, it's contributing a negative amount to this problem. Over here, for a2, you have a positive number. So when we do this, what we're actually finding is the net area. Since our function drops below the x-axis, it's going to give us, what we actually have is, if you're thinking about area as always a positive number, it's giving me negative a1 plus a2. If you can think of it as well, how this changes, there's more area below the x-axis than there is above the x-axis. So it's giving this negative number for the integral. Now that's fine because the question was just evaluate the integral, and that's exactly what we want to do. So this is the solution, and this is the end of that example.